Welcome to the Crazy Wisdom Podcast. I've got Aaron Borger here, and he is the founder and CEO of Orbital Robotics. Welcome to the show.
Hey everyone. Yeah, thanks for having me, Stuart.
So I just did a interview yesterday on robotics from a probably a completely different angle, although maybe not. They did they installed sensing and perception inside of cleaning robots in Europe, and they just got bought by ABB. And so we were talking about all sorts of sensory and how do you give the robots senses. Now probably going to go far off into space and orbital robotics. What does orbital robotics do?
Yeah, so it's actually pretty similar. We have a lot of sensing that we need to do as well, but basically we go up and capture other satellites, provide robotic arms, computer vision software, guidance and control software. So basically, how do you move the spacecraft? How do you move robotic arms to go and capture another spacecraft? So some of our customers can do refueling, repairing, servicing, debris capture, even space station assembly.
I love doing these interviews. Okay, so you capture robots. You're a robot capturer,
Yep, our
and
robots
you're
capture spacecraft.
a robot that captures other robots that are spacecraft,
Pretty
basically.
much. Yep. Yep.
Yeah, and you've got arms. You've got a sense where the other spacecrafts are. There, the what? There's some term for Kessler Effect
Yep.
that
Yep.
if a bunch
Kessler.
of robots hit into each other, are you worried about that? Can you
Uh,
explain what it is for our
yeah.
listeners
So
too?
for the most part, it is once we get so many satellites in orbit, there's a point where if one collides with another, that creates so much debris that then that debris collides with other spacecraft to the point where it's a cascading effect, and now we can no longer use space. We can no longer launch anything because there's so much debris around Earth that we can't do
Whoa.
anything. And so I guess, am I worried about that? I think that that's probably a further problem, like, I don't know, maybe 50, something like that years away. So it's not a very near-term thing, but the cost that it takes to start accounting for all the debris up there will definitely start to increase, since I think with Starship coming online, all the different satellites going up is going to increase exponentially. So then it starts being the amount of cost that it takes to maneuver out of the way and use fuel to avoid the collisions. You might as well just go up and capture it. And then at that point, if you're capturing all these satellites, you have the material on orbit. Why try to deorbit it? Or there's a graveyard orbit where basically there's just a whole bunch of debris hanging out. Why try to deorbit it or
Mm.
just let it sit up there? We could actually use those satellites, recycle them, and basically build new satellites from that. It's kind of like uh, asteroid mining, but around Earth, because we already have the material up there to build new satellites.
And that's speaking of you're actually going to have space factories that will recycle satellites. Is that the
That
way?
that is the long-term vision. Yep, that is the long-term vision. And the near term, it's mostly providing the robotic arms and software to go and capture other
Mm.
satellites. That's the first problem we have to solve. But then after we solve that problem, the long-term vision is how do we recycle these satellites, or how do we gather propellant from the moon and deliver that to satellites in orbit?
Oh, interesting. So I did an interview with Rob Myerson, who I see you're
Oh,
connected to on LinkedIn,
yeah.
and we talked about helium-3, mining helium-3. Is that what you're referring to for the fuel?
So I think helium-3 is definitely a great mineral. That would be a good first, I guess, objective for gathering from the moon. But I'm talking about there is supposed to be lunar ice, and
Oh, interesting.
some like rocket fuel is made from just hydrogen and oxygen, which if you put that together, you get water, which is ice. So you can gather that from the moon and actually split it into hydrogen and oxygen and use that for rocket fuel. So we could deliver that to satellites in orbit, and I think that's a great way to kickstart the lunar economy.
Okay, so that's interesting. So there's lunar ice is the jet fuel. I actually did another interview a couple weeks ago with a guy named Umar Sadiki, and Umar was working for Phase Four. And Phase Four basically figured out this beautiful way of getting a satellite up there. But once the satellite's up there, it runs out of fuel, and then it dips into the upper
Mm.
atmosphere, and then recharges on nitrogen as a potential fuel
Wow.
source as well. Maybe and they actually recently got acquired by another space company. I think specifically for that technology, for maybe that technology might be useful as well. Because you got the jet fuel coming from lunar ice. This sounds like they might have figured out that specific problem as well for how to refuel. So so building robot arms on spacecraft to go capture other dead satellites, right?
It could be dead or it could be alive. We could, like, say, for example, you have a satellite up there, it's already working. We could just upgrade it, for example. That's another thing that we could do with our robots. We're focused on the one problem that enables all these different potential
Mm.
avenues, potential paths. And right now, that's how do you capture a satellite and start manipulating it?
So how do you capture a satellite? Uh, and so okay, well let's go to the space economy, because right now we do have a space economy. That's the coolest thing is, but
Yep.
it's all communications or spy satellite or vision satellites. So you've got two main commercial use cases. I'm hoping to see a lot more soon. But those are the two main ones now, and with an overwhelming dominance of SpaceX,
Yep.
Starlink satellites out there, giving people internet in a lot of crazy spots. Now, then we have the space trash problem, and I've actually got it in my notes to check how much SpaceX is, or how much trash is being created up there. It is a significant problem right now, right? The trash up there.
Yeah, I would say definitely in Leo, there's a point where there's enough debris that sometimes it's difficult to track at the very small pieces. So like centimeter
Mm.
level, that's too small to even track. And so if it hits your satellite, then there's it's very difficult to handle that, but that's also hard to do for debris removal because you can't really go up and grab just a paint speck. So we're mostly determining that you
Whoa.
should just add a barrier or a shield to your satellite to protect from that. We would go after the more medium to larger spacecraft. And at that point, it's like we are working on making it economically viable so it is less cost for us to go up and grab that, push it out of the way of your satellite than it would be for you to maneuver out of the way. So, for example, the ISS, it takes like $1 million. And I think that's actually a pretty accurate estimate, is it's $1 million for the ISS to maneuver out of the way of a larger piece of debris. So we just have to figure out a way to go and capture and push debris out of the way for less than that. But also, it's not like one of our spacecraft needs to be less than 1 million. If we can capture 10 pieces of debris, which are with our spacecrafts, then we need to make each one of those like uh, each debris we need to capture for less than 1 million. So, um,
Mm. Okay, that's really interesting. And so got this debris. I love the part about it being just like a centimeter big, like a paint chip, because you're talking, and you said Leo, which is low Earth orbit,
yep.
and so there's a centimeter paint chips out there, and then there's the larger satellites, and the ISS needs to move out of the way. How often do they need to move out of the way? Is that something that they're constantly doing, or is it something that they just do every once in a while?
I don't know that number off the top of my head.
And so it's just basically like this thing that they might need to do every once in a while. And ISS is up there. There's a bunch of communication satellites up there. There's a bunch of satellites taking pictures. There's GPS satellites. Are there any other satellites? Like what? Like can you what? And you guys go after the medium to large satellites, and then there are like smaller trash objects. Well, can you kind of go into that a little bit longer? Like what is the world up there?
Yeah, I think for the most part, our space economy right now is limited to the Earth observation, communications, those types of satellites. I would love to see a world where we have a lot more humans up there traveling around, but we kind of have to give them an economic reason to be there. At at this point, we're kind of limited because yeah, we already went to the moon in the 60s, but that was because the US government paid for everything. We have to get to a point where some group of people can actually make money by putting people on the moon, for example. And so that's why we're looking at the refueling approach, because if you can take propellant from the moon, deliver that to the communication satellites or the Earth observation satellites,
Mm,
then you give people a reason to be on the moon. Oh, and also
mm,
more robots, because you need to kind of build up the infrastructure first before the people can move there. So that's why I think, yes, right now it's pretty much just communication or Earth observation satellites, but we can use that to kind of bootstrap everything else that we can do up there. But also now there's
mm.
also the data centers, the AI in space, and I really think that that's a great approach as well. And that's another way to drive the economy, the space economy, because we can use our robots as well to go up, help those data centers dock or help maintain them. And then also another salvage opportunity. So just like with the debris,
Mm.
take some of the large solar arrays and recycle that into for new spacecraft.
Okay, and I just looked up some key details. The so total satellites in orbit as of late 2025. There's 15,000 individual satellites orbiting. There's active versus defunct. There's roughly 11 to 12,000 of these satellites are active, while the remainder 3,000 to 4,000 satellites are inactive or defunct, essentially space junk. And okay, that's really interesting. And Starlink has 60% of the total number of operational orbiting spacecraft. Now, you guys are going to send robots up there. And so, do you what is it a prototype? Where are you guys on this trajectory?
Yeah, so we actually have already sent a couple robots to space. Not as a company, but myself and one of my co-founders, while we were students in undergrad, together we put six into space. So our I guess you could say program while we were students, we put robotic arms controlled by AI on NASA suborbital rockets. And so those were designed to throw and catch a ball, a cube, and a wrench back and forth.
So you were throwing balls in space basically
Yep. Yep.
between two sub or what you said suborbital what?
Suborbital rockets. So from the NASA Wallops Flight Facility, it goes up and then come is up there for like 5 minutes, so we can throw and catch, and then it comes back down and splashes into the ocean.
Oh, interesting. And so there's a lot of questions up there. Like one is a personal question, how you ended up in that program where you're throwing stuff into space. But then I want to also understand, well, I guess that's part of it is why or how often NASA's doing this. Is it all with universities and is it all for science? Is it or is it for engineering? Like what's going on there?
Yeah, so personally, I guess that was kind of being in the right place at the right time. My school was a pretty small one, and I actually previously we did a kind of RF experiment where we had a boom that would go out and go back in, and basically test that. I have a really cool video of that o- in space, so you can see the Earth behind it. And then it was my senior year. They're like, "Hey, we need something for our next project," because the NASA does this every single year. It's a program called RockSat. It's basically students only get the opportunity to put experiments into space. And so they're asking, what are some ideas for the next one? And when we came up with, well, let's put some robotic arms on here and try to throw and catch a ball. So that yeah, that it was a lot of being
That's
in the
so
right
cool.
place at the right time, needing someone to lead the team, and I'd already been on the previous mission, so got the opportunity.
What was the previous mission?
The previous mission was the RF experiment where we had the scissor boom
Got
going out and
it.
coming back in.
You rate RF as in radio frequency? What
Yep.
is that?
Yeah, so basically Bluetooth.
And oh, okay, so sending up two ESP32s or Raspberry Pis or some sort of computer
Pretty
up
much, yeah.
there, and then transmitting a Bluetooth between them.
Yep, exactly.
Very interesting. And so you're already in this world, and so then you decided to put up some robotic arms. Now, did you yourself do the robotics, or did you have a teammate who was doing the robotics? How did that work?
So I did all of the software and ended up doing the electrical as well for when it was my senior year. Our mechanical engineer, he's actually at SpaceX now, and then the other engineer that we had working with us was also on the electrical mechanical side. He's now my co-founder. After I graduated, my co-founder took over and did electrical, software, and mechanical for the other four robotic arms. So together, there's so much experience that I actually think the three of us, between myself, my co-founder, and the guy who now works at SpaceX, I don't think anyone else has launched more AI controlled robotic arms to space.
Yeah, and you said AI controlling it. What year was this?
So that was 2022 when we launched the first.
Oh wow! So before the LLMs came out, what AI were you using?
So it's deep reinforcement learning. Basically, we
Okay.
train it through trial and error and simulation. You basically try to catch the ball a whole bunch of times. And when you fail, you figure out what you did wrong and improve.
And was that on Earth? Was that terrestrial that you did the reinforcement learning and then you sent it up there?
It's training and simulation, and then we tested it on Earth. So I have a cool video where I can actually, I move a ball across on a railing, and then our robotic arm goes and grabs it. We had it on our on our website for
Oh, to simulate space?
like,
Was that to simulate space that it's
yep,
on something? Okay,
yep,
interesting.
zero gravity. Yep.
Interesting. Uh, and so the reinforcement learning you did on Earth, and then that was my next question was how do you account for the fact that space is different and there's limited gravity up there?
Yep.
There is gravity in low Earth orbit, right?
Yes, there's gravity, but you're moving fast enough that you're falling basically at the same rate that there is gravity.
Oh, interesting. And that's what the satellites have to account for up there
Yep.
anyway.
Yep, exactly. That's why. So there's still gravity. There's still the exact same gravity as you experience on Earth, but they're moving so fast that they are falling around the Earth and basically miss it.
Yeah. Wow. Okay. So and then you were doing it with reinforcement learning. And so, what are you most excited about in terms of building robots right now? What have LLMs changed the way that you do things, or is it mostly the same?
Honestly, we don't really use LLMs that much. So I think there's a lot of hype right now in the AI world about Gen AI, how you can generate text with LLMs. And I think I've seen some researchers actually trying to use LLMs to control spacecraft, but we're doing something completely different from that. We don't use LLMs. We still use a type of reinforcement learning, but we have a new method that can actually prove that it's safe. So I think a lot of NASA engineers right now who are AI experts, if you ask them, hey, would you use AI to control spacecraft? They would say no, because they all don't believe it. You can do it safe enough. The method that we have come up with is you can use some kind of traditional control methods to actually prove that while we're using this neural network to control robotic arms and the spacecraft, it will do exactly what we want it to do every single time.
Mm. And it's a reinforcement algorithm. Maybe you should talk to the guys that I talked to with yesterday. I'm sure they'd have some interesting insights for you as well. Because it's physical AI, because it's how do you sense things?
Yep.
How do you sense? And it's interesting because we were talking all about we did this. He talked about this Monte Carlo perception thing where
Yep.
it's like you put out points into space, and then depending on how you move, the points will tell you like where the robot moves. So it gives it sort of a sense of space time, and but at space, it's just like stars and nothing else, right? Like well, yeah, the Earth, I guess you could sense the Earth, right?
Yeah, yeah. So we do Monte Carlo approaches as well. It's basically we can start the spacecraft with the robotic arms in a bunch of random different positions, orientations. The robotic arms are in different configurations. And then we make sure that regardless of where the kind of initial state is, we make sure that it will move to exactly the state that we want it to, which in one case would be
Mm,
grabbing onto another satellite while it's tumbling and then detumbling it. Because that's another issue is a satellite that's dead or a debris is going to be tumbling because when you launch it, they have reaction wheels or control moment gyros that are spinning. And so once it stops working, all that spinning momentum transfers into the spacecraft itself, which makes it tumble. So you have to basically tumble your spacecraft to come.
that's crazy. Okay, so tumbling reaction wheels. There's a robotic arms. And just that's the hardest part about space. I mean, but that's the cool thing too, because I'll share a little bit more about kind of the way that I see the technology world. The last 20 years have been about satellites and space, or sorry, I'm sorry, last 20 years have been about software. So SaaS software basically, and it's sort of like a boring vision of technology where it's just like, yeah, it kind of helps you do the business, but then all the real business got offshored. So like all the real productive manufacturing got offshored to other countries, and it's sort of like just like a Ponzi scheme since 2008. And then LLMs come in and are basically showing everybody where all the BS jobs are, because the LLM can do the BS job much faster, and with no pretending. And so it's kind of like, we got a house of cards economies where, from my perspective, maybe a little bit cynical or pessimistic. I am an optimist, but then so it's all just kind of like shipped off. You got software, technology has become software, and now AI is kind of like making all the technology of software kind of easy. I'm building applications now. There's no real blockages anymore. I've got LLMs that are just coding applications for me. Sure, they're not like meant to be millions of users, but the idea of having an app that's used by millions of users when anyone can just farm their own software is also kind of may change that whole negotiation. So it feels like we're going in a massive, like, sort of like orthogonal direction than the last 20 years, and that's always hard. And you're it seems like you're a little bit younger, just out of university, I think. Maybe it's been a while.
I worked
Is that
at Blue Origin for like 2 years and then went on worked on for a PhD for a while and then decided, you know what, I'm gonna start the company. So it's been a couple of years out of
so you're in your 20s basically, right?
yep, yep.
Yeah. So you're kind of like, I'm a millennial. I just turned 40, so it's like I'm like, I've my whole since I was your age, that everything I just described has happened now. And now it's like a far out of far right field or left field or whatever. There's just like crazy AI coming, but not only AI, also robotics, also so I'm building this. I've got this guy. I got this bought this guy from China, and it's a for microphone,
Oh,
and so it's got so I'm going to create my own Alexa, but
mm,
it's going to be an agentic Alexa, and
cool.
I'm not coding any of it. I'm letting the AI go, code everything, which is really interesting, and it's worked so far on the other projects. And so like, and then we got space, and then we got technology for space, and it feels like a very hard problem. And I've done so many interviews. Like, there's the single event upset or something
Yep.
like that. There's
Single
like,
event ups
yeah, like,
where
yeah.
there's
Can you talk more
radiation.
about that?
Yeah. So that's another problem that we have to deal with is at any point radiation could corrupt your processor, and you could be basically on a trajectory to collide with another spacecraft. Then radiation hits, and you have to basically reset the processor and get prepared to continue capturing. So, one approach that you could take is kind of the old NASA approach, where they spend $100,000 on a processor that is robust to radiation. We can't do
Wow.
that because then we can't make any money. So we
Yeah.
use more automotive grade components that we make radiation tolerant using some smart software and electrical approaches. And so basically, we can just reset the controller super quick if there is a single event upset and continue operating. But at the same time, we need to execute our guidance and control, which is basically how do you figure out where you want to move the spacecraft? How do you produce torque and thrust to move it? So that at any point, if that single event upset occurs and you have to reset your controller for, I don't know, up to 10 seconds, you won't collide with it. They call it like a passive safe trajectory where you're passively safe regardless of what happens, you would not collide with it. And you have to do that all the way up to where your arms are about to grab it. If for some reason there's a 10-second, or it'll be a little less than that, but if there's a 10-second period where you don't have control over it, you have to make sure that you won't collide and damage it.
Wow. And is it just all because it's up there, and it's outside the atmosphere, and the atmosphere protects our terrestrial equipment from cosmic
Correct.
rays?
Correct. And really, Leo low Earth orbit isn't too bad, but once you get into
Okay.
Leo or cislunar, so basically around the moon, then it's a lot more difficult.
uh, Man, it's so crazy. So we could talk more about that sort of radiation stuff and robotic arms, but I believe Artemis, or there is a trip to the moon that's being planned right now, right? Like, we're about to go back to the moon. Do you know
There's
anything about that?
supposed to be. I
Okay.
think I Honestly, I don't know how well the NASA effort will do, but I do think that SpaceX and Blue Origin both seem to be doing pretty making really good progress towards that. So,
Wait. Oh, okay, but they're not part of that project. Is Artemis? And if you don't know, it's fine. But like, is Artemis partnering with SpaceX and Blue Origin
yeah,
to get people to the
yeah,
moon?
NASA is partnering with both SpaceX and Blue Origin, but there was also an additional effort with the SLS that was supposed to go up.
What is the
Yeah.
SLS?
Space Launch System, I believe.
Uh huh. Uh huh. System. Super interesting. Okay, so there might be a trip to the moon, might not be. Uh, oh man. Okay, so let's go into robotics. What do you like? I know that in the United States, any space company sort of needs to have all of their supply chains or all of their intimate supply chains in the US because of regulations and such, which actually is
Yep.
kind of good compared to everything else in the economy, given what I was talking about earlier. And so, is it like a vibrant? You guys said you already put stuff into space with NASA. Is it a vibrant thing? Like, is there an economy that if you're building space stuff that you can get things you need, like in a marketplace or anything like that?
I think at the moment it's difficult because it's
Yeah,
expensive and there's lead time.
yeah,
So
expensive. Yeah,
since a lot of these space companies want to go through the same manufacturing companies, one,
yeah.
they can increase the prices a lot because there's a lot of quality that has to go into these components.
Yeah,
But then
interesting.
also all of them are going to the same manufacturers. So we're looking at space grade motors were 24 weeks out, and it's really difficult to build the amount of robotic arms we need, which is like 30 per year. And just 2 or 3 years from now, it's going to be very difficult to build that amount. So we actually have some manufacturing partners, which are the same people that manufactured the Blue Origin BE4, BE7 engines. They basically were working at Blue Origin, left to start a company, and now we're partnered with them. And maybe back on some of the moon stuff, I still think Blue Origin's doing pretty good, and I hope they do good because some of my software, I was the lead software
Mhm.
engineer for the BE7, their lunar lander engine. So if they do go to the moon, some of my software would be on that route.
Oh,
So
interesting.
I'm wishing them well.
Okay, lunar lander software. What type of software does a lunar lander need compared to the kind of SaaS software I was talking about earlier?
It's a lot more take in some sensors, read temperature, pressure, speed, and output valve movements. So how do you
Oh,
move the valves of the engine? And then also you still have the radiation issue that's much worse towards the moon. So how do you account for that? And then how do you take in commands from the spacecraft? This is specifically for the rocket engine part of it. How do you take commands from the spacecraft? And then how do you communicate with the spacecraft? Give it information of what's going on, detect if any of the sensors, any of the motors, things like that go bad, and figure out what to do if it does go bad.
okay, that's really interesting. So, is this an internal combustion engine that on these lunar landers?
I think every lunar lander is different. Our specific engine,
Oh, interesting.
it's the BE7, so it's a dual expander cycle engine. And if you asked me more details about that, I would probably just say, well, the propulsion engineers told me what to program. I just
Yeah, interesting. Okay,
software.
interesting. So, oh, because there's also jet engines, of course. Because so there's like internal combustion engine, which is the car, and then I'm sure a bunch of other manufacturing things, and then there's also a jet engine. And there's but this is like a real. The reason I was asking it was because there's like an electric. We've got electric cars now as well, and so I wonder. But the batteries are probably very heavy, so I probably don't
Yeah,
want
and
to put a
kind of the
battery.
difference
Yeah.
between those so like a car, for example, the engine produces power so that you can turn a wheel. The jet engine will produce a thrust out the back, but it takes in
Uh,
oxygen from the air. The rocket engine has to take up oxygen and its fuel and then spit it out the back basically at a high speed to produce thrust and a force so that I can move it forward.
Oh, interesting. Okay. Okay, and so you're building the software, and it's got valves and all these things, and you're talking with the engineers, the actual the propulsion engineers, the rocket scientists. It's such a crazy world that we're entering. How does it? Because it seems like you got into a very interesting part. Like first out, was that your goal when you were going to school was to get into space?
It was partially the reason I went to Blue Origin is actually they had a thing they were working on called Space Ross, which was basically Ross's robot operating system that was supposed to be how you control robots in space. They were working with another company, and then right when I got there, they said we aren't going to work on this anymore, and so I was placed on the BE7 team, and that it actually was great because I learned so much, learned about how to actually put our software on rocket engines. Also did some AI and machine learning for predicting the health of rocket engines just from temperature and pressure sensors. And so that was learning a lot about how you can actually make AI robust enough to use for aerospace.
That is super interesting. So predictive AI for engine health. Um,
Yep.
was that reinforcement learning as well?
That one was more I guess they call it supervised learning. It's basically you provide an input and then you provide an output. We already have an indication of like how healthy the engine is at various
Mm,
time steps. And this was more focused on specific components, like a bearing or a valve, stuff like that, or the nozzle of the engine. You need to figure out how much time you had before you need to replace it. And so we were just taking in temperature and pressure sensors from that. Some of the difficulty is every single engine is slightly different when you manufacture it. So you can't just train on data from one engine and try to apply it to another. You have to
oh,
account for, okay, gather some data from this engine and then adapt your neural network to that to account for it.
wow. Okay, man, it's getting sci-fi. So each engine is different
Yep.
based on the way it's
Manufactured.
manufactured.
There's tolerances for how you manufacture it, but even small changes within that tolerance creates different engine dynamics.
Manufactured. And so to sense it, like with the AI, was there something like this, like an ESP32 or a microcontroller or something? Is that how you actually get the sensor data?
They did have a microcontroller, yeah, it's more a production ready microcontroller, um, but yeah, that gathers all the temperature, pressure, acceleration, that kind of data, and then we input that to our neural network model after collecting that from a couple different engines, also combine it with simulated data because you don't have enough fail like degraded performance rocket engines because usually they don't really build enough to gather enough data. So you have to simulate some of that data as well.
And is that synthetic data? Is that the same thing as synthetic data?
Yeah,
Or
same idea.
uh huh. Um, Man, it's so cool. It's so there's so many different ways that technology can be applied, and there's so many different sort of like little rabbit holes to go into relating to this. And it's fun because all the things I just showed you for the hardware, it's like those have only entered my life in the last few months because now I've got this LLM who is basically like a private tutor who
Yeah.
teaches me anything I want to know. And it's like just opening up all these different worlds. And so I'm starting to think about all these different new applications of technology because now I understand what a computer is. And that I'll give you my vision of where I think AI is going. I mean, most of it's LLM based, but I do recognize that what you're talking about is real. That LLMs are not a silver bullet. They're really good for private tutoring. They're good at coding so far. They're probably gonna get a lot better at coding, but they lack reasoning. They lack self awareness. They don't have a world model. This is what we were talking
Yeah.
about yesterday, was that there's just no world model. So there's no way to have that self-referential understanding of where I am in the world, and like move around it. And based off of that, that's how you get reasoning. And these just like hallucinate reasoning. They're not actually doing reasoning. Um, so AI, it feels like it's just going to totally revolutionize a lot of the ways that we build software. Uh, and software is so important for hardware, as we've been discussing. So it feels like it's going to be a pretty important change that we're going to head through just by the mere fact that software is now way, way easier to develop. And our whole world is so dependent on software as well. What do you think? Do you think that's, do you agree, disagree? What do you think?
Yeah, I think a lot of what you're talking about with the world models and the LLMs maybe not being sufficient enough is definitely some thoughts that we've been talking about as a company, and a lot of this also comes from Jan LeCun. So he was, I hope I'm saying his name right. He was the chief
Yeah.
scientist at Meta, went off to start his company, and a lot of it, what he's talking about is we should be focused on world models, AI that understands the physics of the world, and that's a lot of what we're doing is we're actually using physics equations that describe how the spacecraft
Mm.
move relative to each other in orbit, and we train the AI to understand that and make predictions of how its behavior, how it moves the robotic arms and the spacecraft will affect the environment, the world, based on those physics
Yeah.
equations, rather than kind of the older reinforcement learning approaches are just we'll gather some data from the world, try to predict how our actions affect the world. Rather, we
Yeah.
are
Interesting.
creating AI that actually understands some of those physics equations.
That's really cool. So uh, it reminds me of, I can't remember where I got this, but somebody told me that LLMs are based off of the idea that it's faster to guess than it is to know.
Yeah.
So you know these things are just guessing, and what you're talking about is knowing something. And it reminds me of symbolic AI and neurosymbolic AI, which like symbolic AI was from 1960s to 1981, and that was like like that's how we got ontologies and all these things of like how to actually encode hard code logic and all these things into the and then that didn't work. It didn't work for AI. A lot of people are wanting to get it back because LLMs hallucinate, and this might be the way to actually stop the hallucination. And then the convolutional neural networks took over and basically just created like why put your money anywhere else when you can put your money into what are now transformers and all these different things, and like why invest in anything else when you can invest in this. And then we got the thing I was talking about earlier with 2008 and sort of like the Ponzi-nomics, which we now have a lot of, and like that how that changes investors. And now they're piling into LLMs. You just call it AI and get a bunch of money.
Yeah.
Just reading about like 2025 how the venture market is totally destroyed. None of the venture capitalists have been able to raise money from their LPs
Hmm.
because of what happened in 2021, which is that all the companies were valued at giant valuations because of all the money coming into the system.
Yeah.
And now there's no way that they can actually pay their investors back because it was too high of a valuation.
Yeah.
So maybe after that, maybe after this year, maybe in a couple of years, VC will kind of return to normalcy and then might actually start investing in space. Actually, that'd be a good question to ask you about space VC, because it's still like space. From my understanding, is like what the PC was in 1980s, where it's not something where everybody's involved. It's a small community of people who all know each other, and like now, so it feels like the PC industry. Is that how the space industry is right now?
I think that's a great way to describe it. Yes, it's very small, and I think most people who are kind of the leaders of the companies all know each other.
Yeah,
And once you meet a couple, it's very easy to meet everyone else. So it's also just very difficult to kind of get your name and talk with the
yeah.
first couple to meet everyone else. But yeah, I think it's very early, and there are VCs that are space only. That's their core.
Oh, interesting.
They've invested in SpaceX. They've invested in all the other space companies,
Yeah, interesting.
and I
Yeah,
I think they're doing pretty good.
yeah. Man, I'm so excited for whatever happens next in terms of the space economy because it does feel like we still haven't like everything I just said from 21 till now. Like that's probably messed with the market a bit, but also maybe hasn't because there's also been a huge amount of interest because of SpaceX. But the fact that we can just launch things, you as a student, you benefited from SpaceX's launch capabilities in your studies, right? That was because of that new thing that happened,
It
right?
it did help, but this was on a separate rocket. It's basically a
Oh,
created missile that was able to launch into space and do student
oh,
experiments. Um,
oh,
that one
got it.
wasn't on a SpaceX rocket, but some of
Yeah,
our next missions that we're planning and have scheduled, those will be on SpaceX missions.
but regardless, like essentially, like SpaceX has opened up the ability to make tests inside of
Yep.
space, business tests to see whether businesses work.
Yep.
Um,
Exactly.
and so obviously you're very into robotic arms and you think robotic arms are going to be important. I agree with you. Any other like, and then we've got as we talked about communication satellites and picture satellites. Are there any other sort of things I've done an interview with Matt Gialik from Astroforge.
Hmm.
Asteroid mining seems interesting.
Yeah.
I did the interlude one where they're going to go mine helium-3. Any other types of things that I should be aware of, or my listeners should be aware of in terms of the emerging space economy that you're really excited about?
Yeah. Well, I think I like the convergence of AI and
Yeah,
space and
yeah,
robotics. But
yeah.
I also think that the AI in space, there's already some where it's training AI. There's some where it's using the AI to track things on the Earth, figure out what objects you're looking at on the Earth. But it's very new to actually control spacecraft with AI because
Oh,
until now, until we have developed some of our newer algorithms, you can't prove that the AI will work, and so it's a safety issue. But now we're at the point where, okay, we know exactly what this AI will do. We can predict what it will do in every situation, and
mm,
now it's safe to perform much more complex maneuvers, which is why, like,
mm,
there's been very little US missions that have gone and captured other spacecraft just because it's so difficult to
mm,
every robotic arm motion or even just a dock. So the AI, I think, will also enable a whole bunch of new stuff and enable autonomy even on the moon. They use some AI on Mars, so for like
mm,
the rovers, but I it's also difficult to tell, is it AI as in just very smart software or is it actually neural networks? I think as a AI community, we aren't doing
yeah.
very good at describing exactly
Yeah,
what terminology
that's
we're
a
talking about.
that's always the problem, right? Because it's like the just AI is the worst defined thing in the world,
Yep.
including from insiders. I remember when I started working at this company called Invisible Technologies that was helping OpenAI do RLHF.
Hmm.
Basically, like nobody knows what artificial intelligence means. It's such a moving target, and as soon as we hit a bunch of things like I clearly LLMs pass the Turing test. But then the AGI is like, oh no, that's not AGI because we just
Yep.
we just did it. So AGI is just like this always this thing in the future, and it's like poorly defined. Um, so uh, I love and so you said algorithms. How much like they used AI in something, but how do you know what's actually the AI? Because did they ship a GPU up there? And it's also like NVIDIA has GPUs that are space hardened, right? Like there are radiation hardened GPUs.
I'm probably not at the forefront of some of their knowledge of what they're developing,
Yeah,
but I do know that StarCloud did launch a GPU to space. So
StarCloud did.
I'm
Okay,
sure they figured something out there. We have also launched NVIDIA Jetson Nanos on those
okay.
robots that we launched suborbital. So they seem to have been fine. We didn't do specific tests to see whether they would withstand radiation, but also it was only up there for 5 minutes. So it wasn't that big of a test for the GPUs.
So an NVIDIA Jetson Nano in
Yep.
21 or 22, that was a thing that basically you could send
Yep.
it up there and do the reinforcement learning to check the ball was
Yep.
going on the
That
straight
was
line,
one of their
basically.
first GPUs. We did computer vision so we could figure out where the ball is at,
Yeah.
and then also it's basically just executing the neural network. You don't really have to train on orbit, although you should because whatever you do in simulation won't precisely represent the real world. So,
Mm.
but yeah, those were just executing a neural network and computer vision.
What have you learned about design tolerances in the past few years? Like, so I'm getting into tinkering, and like my main goal, I don't really have that many goals besides just tinkering and seeing how far I can take the AI. And so far, each time I come up with an idea, I'm able to do it, which is like magical for me. It's like very cool that I can do that. And so I try to ask people who know what they're talking about and kind of who have built software and hardware and all these different things to try to like help me understand some of the implicit knowledge that they've won through essentially just doing all these crazy things. So like what should I know about design tolerances and working with the physical world and working with hardware? What are the things that you've learned in that area?
By design tolerances, are you mostly meaning like how the different components fit together in a mechanical system, or
So I don't have any. I don't know. I was just
okay.
I just
Yeah.
a random word like an LLM. Yeah.
So one thing that I think about transferring AI to the real world, kind of along that lines of every rocket engine is different. We also have the problem where every robotic arm is different, every spacecraft is different. And so we can kind of simulate stuff in simulation, but it won't be completely accurate to the real world. So we actually have to do we call it system identification method, where after we launch our robotic arms in orbit, we move them around a little bit, gather data from that, compare that to the equations that we use to simulate, and then we have to make small tweaks to make it more accurate, and then retrain, and then verify that that data we collected on orbit is now precise compared to our system model, our mathematical equations. And that guarantees that when we train our AI, when we train our neural networks to control it, it's now using an accurate model of the real world.
It's so cool. Uh, and okay, and I think I got my answer, which is basically a huge part of doing this crazy technology stuff is modeling it out beforehand and
Yep.
mathematically modeling it out and then simulating it and then trying and comparing with the simulation what actually happens.
Yeah, I think a lot of the AI development is more using AI as a crutch for not really understanding exactly
Those
how the
things.
system works. Because you can just throw a lot of data at it, but then if training it doesn't work, it's really difficult to figure out, okay, what do I do next? Versus if you really understand all the
Yeah.
physics behind it, model all the physics, and there's a couple methods that we use to make sure that the AI learns exactly how the physics works. Then it's really easy to tell, oh, I'm moving too fast. I need to slow down. And then we can adjust some of our objectives that we use to train the AI.
Hmm. That's a really good point. It gives me an idea. We've got this group here in Buenos Aires, Argentina, called AI Whisperers, and I've been learning all this stuff, and then I teach them how to do it. And so we've been mostly just building software, but then about a month ago, it became really easy to build software, and so I started hacking around or tinkering with all these little things. And a huge part of what I like doing is both learning it from my understanding, because now I have a tutor that can teach me how the systems work. Yes, of course, it's not 100% in software. It's actually like really good. It understands all of the software, and as the data training gets better and better, and they go get all the hardware, the textbooks, all the space stuff, as long as it's sort of public and out in the open, then it gets better and better at understanding all the other branches of science and technology. So, and that's the funniest thing about it is, and which is just like the hype is crazy because all these people are going lovable, building all these things, and they're able to prototype, but no curiosity, no interest. And it's like not everybody needs to learn this stuff either. Uh, uh, but everybody's just going out there building stuff, being like, "Oh, that's cool," and then it is cool. They do get a new application, but there's sort of no learning as to how to use it. The cool thing about it is that you can do both. You can both tinker and you can use that, like what you're saying with the model, except it's a model in my head where it's like I tinker, understand where it fails, and then that's the modeling part. And then I go learn why it fails. And then I have a better world model inside of my head as well.
Exactly.
Um,
Yeah, and I think
yeah.
maybe that's one of the downsides with LLMs right now is it does enable a whole bunch of new people who can pretty much program. They can create new
Mm,
apps, web applications. The only difficulty is if you try to build, let's say, a deep tech company around that where your software is controlling
yeah. There's no
hardware,
way.
especially satellites in orbit, you want to make
Yeah.
sure that every piece of software is doing exactly what you want to do, but if you start
Ah,
generating code with the LLMs, then it's very difficult to have a human who understands that you really don't have that understanding of how every piece of the software works, which may be okay if you can generate it once and get it to figure out. But then let's say you decide you want to change something, you want to change the behavior, it's really
Hmm.
difficult to go in there and know, "Okay, I need to change these lines of code," because you don't understand how every line of code works. So, yeah, we don't really use LLMs to generate our code. We more train neural networks to control our spacecraft, our robotic arms, which is somewhat of a different approach. I'm
Hmm.
still really glad we have the LLMs though, because now everyone can create a website, or an app. I think we should kinda limit it to some of the less safety critical,
Yeah,
pieces
that
of work.
and this is the big thing we talked about yesterday was just like inside, according to regulation, inside of the industrial manufacturing stuff, everything according to regulation inside of anything that requires safety needs to be deterministic,
Yeah.
and completely deterministic, and will be able to shut off immediately. And that actually allowed this company we talked about yesterday to do their thing inside the sandbox as long as they never went into that deterministic thing. They only operated before the deterministic like hard cutoff,
Got it.
hard safety cutoff switch, basically. And so I had another thought about, oh yeah, so we were talking about how it's like bounded. Things need to be bounded in certain things, and there's all these like it's like the same way that Anthropic is testing out their models, which is they put it inside of a sandbox, inside of a container that it just can't get out of because
Yeah,
it's a virtual computer, and then they test it to see what it does, and then inside of this sort of laboratory, and it's all under this problem of interpretability and black box because the
exactly.
LLMs and AI are a black box. We don't know what's going on, and we don't have neuronal interpretability either, like how each of the neuron is working inside of the network.
Yeah,
So there's no, and Anthropic is getting closer. These people are getting closer to getting some of the neurons to finding out. And the way they're doing this is putting it inside this box and saying you can't get out, and like testing the visible ways in which it succeeds or fails. And that's my approach to evaluations. It's like I don't trust the third party evaluations. I just trust what it's able to do, whether it works or not. And I'm based on what you said, I feel like there's a method of how do we do that, but then get some sort of interpretability and study, even though the AI kind of does a lot of it because it'll just get better and better,
yeah,
how to like get knowledge of the entire system. It's almost like a scholar,
yeah.
like studying what it does, basically.
And
What do you think?
we definitely use the determinism and the bounded approach as well. So our determinism approach, basically, if the spacecraft and robotic arms start in the initial state, by state I mean like the position of the arms, the velocity of the spacecraft, all that. If that stays the same, the neural network produces the exact same output every single time.
Oh,
So
interesting.
from there, you know that as long as the same thing happens, it will continue on the same trajectory
Yeah,
you
yeah.
expect. The bounded approach, during our training, we make sure that, for example, it will never go faster than 10 meters per second as we're trying to approach this other spacecraft. And we bound it and make sure that regardless of the initial state, the initial speed, it will always slow down, or even we add noise for some of the other parameters. So we make sure, okay, we think it's 100 kilograms, but if it's actually 110 kilograms, it will still not go faster than 10 meters per second.
Oh,
And so we bound it just like that.
really interesting. All right, in last few minutes, there's like, do you think China's like building warfare stuff in this sense? Do you think they're like building things like attack satellites? I'm sure they're building attack satellites, right?
I I have heard that they have built a satellite that could go up and grab another satellite, which is
Yeah.
exactly what we are developing. And I guess I probably don't know or don't have the full understanding on exactly what they plan to do with that, what some of the other demonstrations they have, but at least my thinking about that is we should build up our defenses just to
Mm,
deter something from happening. It's kind of I don't really want to build a bunch of weapons to go hurt someone else, but I
yeah.
do want to make sure that we have our defenses built up to help deter something from happening. Mm,
It's kind of crazy because it's almost like because in the 1970s these were the same questions that were being asked right now. Is the same questions about
yeah,
militarization of space, and we decided not to do that. We decided with the Soviet Union there was a sort of a detente, And we're like, no, we're going to cooperate. Space needs to be international. And now it's interesting because I was thinking that, I mean, that might still happen. I sometimes question how much of an enemy China really is. It keeps on going back and forth. It seems like we're very codependent as economies. Like if either of one of us kind of like slipped away, the other one would fail. It feels like we're in a situation that's very different from the Soviet Union. Um, and but but and then there's also the recent national security thing that the administration recently put out of the we're going back to Monroe 2.0 doctrine. So it means that we're headed back just to guard the Western Hemisphere, and everyone else can kind of do what they're doing on the other hemisphere. And it's actually a question though, because it's like, are we able to do that in the satellite realm? Like, can we? Because we'll have satellite. Well, no, the U.S. definitely is not giving up all of the satellites all around the globe. Like those are going to remain. So it feels like space is not bounded by terror. It's not bounded by what's underneath that part of space, right?
There are some I guess agreements where, for example,
Yeah.
if you have an FCC license, you have that for a certain spot in orbit. So you kind of claim
Uh-huh.
that spot in
Oh,
orbit, so you
interesting.
can communicate from there. And I'm not fully up to date on how all
Yeah.
the agreements work and how all the different countries cooperate. But I do really think that if there were to be some kind of conflict in space, that would be devastating because we already talked about the Kessler effect, where once you destroy one satellite and create a bunch of debris, that creates the cascading effect. So I think we want to do everything that we can to prevent that from happening.
Mm. Yeah, it's almost like a bit of mutual assured destruction there too, because I'm sure
Yep.
China also has this sort of like sense that a huge amount of their prosperity is dependent on
Yep.
what's in space already. And if we start shooting that down, it's like, oof, that's a line that probably neither party really wants to cross.
Exactly.
Well, thank you so much for coming on the show. Do you write about this? Do you produce any content? Does your company kind of explaining more about what you do? Anything, anywhere our listeners can tune in?
Yeah, we have our website right now, mostly demos of some of the products that we're working on, but we're also very quickly working on our next mission. So we have some on-orbit demos scheduled, which we'll be releasing more info about shortly. And as we develop our technology, we'll be producing more basically demonstration videos on how that's all working.
Cool. And
They
so
could
they can
also
find it by,
follow me
or
on LinkedIn or website.
so they can go to Orbital Robotics to go find more Aaron Borger.
Yep.